Okay, so we spent a few days in the lab learning how to find limits graphically. And while this is a fairly good method for finding limits, it's not very efficient and it's not very precise. It's best at just giving us a feel for how to find a limit. So we need to develop a better method for finding limits. That better method will be to find limits algebraically. So we're going to look on the next slide at a process for finding limits algebraically. Our first step is going to be to plug the x value a that we are approaching into our function f of x. This is going to give us a number, and we're going to characterize that number as the fraction b over c. We're going to take a look at that number that we get, b over c, and consider it as belonging to one of three cases, which will help us determine what the limit is. So our first case is the best case and the easiest case. We plug x equal a into the function, and we get a resulting number b over c, and that b over c is the limit. So b over c is the limit, but we note that this is the case when that denominator c is not 0. So we get an answer immediately in the case when the denominator c is not 0. And that answer is b over c. What's so good about this case is that we have the answer to our limit obtained immediately. As we'll see, in most cases, limits aren't that easy to determine, and this case 1 is actually a subcase of the cases we encounter most often. So let's look at case 2. Okay, so in our case 2, we plug our x equals a into the function, and we again get a fraction b over c. This time, however, the denominator is 0, and we have to note that the numerator cannot be 0. So what's happening in this case? In this case, with the denominator being 0, the denominator is actually 0 when we plug in x equals a, we actually have a vertical asymptote for the function in this case. So the function could look something like this, and does in many cases. So it approaches the vertical asymptote from the right like this, going to positive infinity, and it approaches the vertical asymptote from the left like this and has a limit of minus infinity. So in this case, what happens is we get a 0 denominator I'm plugging in, and we wind up with a left limit and a right limit of either plus or minus infinity. So here we have a 0 denominator and a non-zero numerator, and the best thing to do is to determine the limit graphically. Draw the graph and see what happens to the left and right of the vertical asymptote. We'll look at this more carefully when we study case 2 in more detail in later videos. So now let's go on to our case 3. Okay, so now we're at case 3, the third and final case, and the most important case. It's the case where when we plug our limit a in, our limiting value x in, x equals a in, we get b over c, and both the denominator and the numerator are 0. So the first time you encounter this, it's odd. We've got a fraction where both the numerator and the denominator are 0. So we have to figure out a way to determine what to do here. How do we handle 0 over 0 limits? Well, it's actually not that hard if we learn the various approaches that we can take to handle them. So let's start looking at them. So we're just going to look at 0 over 0 limits very generally at this point and identify the key thing that we want to do, and that is to remove the factor in the denominator that is 0 by pairing it with the same factor in the numerator and canceling. Sounds easy enough, and it is once you get the techniques down, but we need to take a look at those techniques to see how to do this pairing of these factors and do the canceling. And we're going to do that in subsequent videos.